afternoon, all of you. Excuse me, Navid. Good afternoon, all of you. In today's session of class 12 physics, we are going to continue with the chapter capacitor, and today we will discuss a new topic that is called introduction of dielectric between the plates of a capacitor. So the first thing you have to understand is that what is the meaning of the word dielectric. Okay, so dielectric literally means insulator. So what we call insulator, that is actually dielectric. Now what you have to understand is that suppose you have a conductor, okay, or you may have a polar dielectric, that is polar insulator. Or you may have a non-polar dielectric, that is non-polar insulator. So if you have a conductor, what happens in a conductor is that in a conductor, when inside the conductor they arrange themselves opposite to the field, and the positive charges arrange themselves on the same side as the field. So the free electrons, they arrange themselves opposite to the field, and the positive charges arrange themselves on the side of the field. And due to this arrangement, a field is created inside the conductor, so I am calling that as E dash. So what happens is that the applied field E and this field E dash, they both cancel each other to give a resultant field of 0. So that means the applied field E and the field E dash, they both cancel each other, and the resultant field inside the conductor is 0, right? So in electrostatics, whenever you apply a field on a conductor, the field inside the conductor is always 0. And by the way, this arrangement happens in nanoseconds. There is no time lag. So for all practical purposes, you can make a sweeping statement that inside a conductor the field will be 0. Now we move on to polar dielectric. suppose you apply a field E on a conductor. Okay, let's say you apply a field E on a conductor, and due to this applied field E, this is a polar dielectric. Now, when I say polar, you have heard of this word in chemistry. You know, polar means that the molecules have different charge centers. The negative and positive charge centers are not at the same place, they are separated. So in a polar dielectric, you can represent every molecule by a negative end and a positive end. So when you apply a field, then the negative end of all the charges will appear on the left and the positive end of all the charges will appear on the right, and this arrangement will create a field E dash. However, unlike a conductor, in a dielectric, the subtraction of E and E dash will not be zero. It will be E divided by a factor K, where K is called the dielectric constant. K is called the dielectric constant. So once again I am saying, in a polar dielectric, when you apply an external field E, then the molecules have polarity, that means they have charge separation. There are no free electrons, but the molecules have charge separation, and the negative ends of the molecule appears on the extreme left, the positive ends of the molecule appears on the extreme right. So an inbuilt field is created inside the dielectric E dash, and the subtraction of E and E dash is E by K, where K is called dielectric constant of the dielectric. So if you now compare this with the equation which we had written for conductor, so for conductor it should be E by infinity because it is 0, so it should be E minus E dash is E by infinity. So for an ideal conductor, the dielectric constant is infinity. Just to give you an example of polar dielectric, for water the dielectric constant is 80, right? The water is, you all know that water is actually not conductor, but it's among insulators its conducting power is a little better than other insulators, and in fact the dielectric constant of water is 80. Now let us talk about this next one, that is non-polar dielectric. So I have applied a field E. So in non-polar what happens? The molecules don't have charge separation, but under the influence of this field, the charges will separate. So under the influence of this field, the charges will separate, and finally E minus E dash is E by K, and just to give you an idea, for air or vacuum, the value of K is 1, right? So for air or vacuum, the value of K is 1. So this is the topic, insulator or dielectric. Now what happens is that in a dielectric, there is an extraordinary situation which may happen, that the applied field is so strong that it will just rip the electrons out of the atoms and the electrons will become free, right? So when this applied field is extremely strong, then the polar molecules, they may start having free electrons due to the extraordinarily high field, and those free electrons will increase the conductivity drastically. So when that happens, we say that the dielectric has suffered a breakdown. That means the dielectric has become conducting. So whenever we say that a dielectric has broken down, so we measure the dielectric breakdown strength is measured by the value of E such that the field inside becomes 0, just as if it was a conductor. So every dielectric has a dielectric breakdown strength, and that breakdown strength is the value of E for which the field inside becomes zero, just as if it was a conductor. Okay, now suppose between the plates of a parallel plate capacitor, you have introduced a dielectric. So let us say that this is the positive plate, this is a negative plate, and between the two plates, you have introduced a dielectric. So due to the introduction of dielectric, you can see that there will be polarity, like for example, the upper plate of the capacitor is plus, so the nearer end of the dielectric will be minus, and the lower plate of the capacitor is minus, so the nearer end of the dielectric will be plus. So one field will be created E dash, which will be opposite to the actual field E, and the relation will be E minus E dash will be E by K, and E is Q by A epsilon naught, so Q by A epsilon naught into K, and this will be equal to V by D, where V is the potential difference. So ultimately the capacitance C will be Q by V, that is Ka epsilon naught by D. So this is the formula to find the capacitance of a capacitor in which a dielectric has been introduced between the plates. So there are some more theories related to dielectric, but we will keep it till here, and now I will give you the usual homework. Okay, all of you, these are the three homework questions. So the first homework question is that in a parallel plate capacitor, the area is 100 centimeters square. The distance between the plates is 0.05 centimeter, and it is given that the capacitance is like with a dielectric, the capacitance is 3.54 into 10 to the power minus 10 farad. So the question is, what is a dielectric constant? This is question number 1. Question number 2, P epsilon naught by D is 0.004 microfarad. K is 2.5, distance is 0.025 millimeter. So what is A? Question number 3, the potential difference between the plates is 200. Area is 100 centimeter square. Distance is 1 millimeter. What is the charge? And if the dielectric constant is of a dielectric is 2.5, then what is the potential? So these are the 3 homework questions. And as always, you can submit your homework by 9 p.m. tomorrow. That will be all for this session. I'll end now. Thank you. Bye all of you.